Today we're going to talk about neutralization reactions for acids and bases. When you have an acid and a base that are reacted together, the products that you're going to form are going to be a salt and water, and you're going to see why this happens in just a moment. Now remember, there are lots of different kinds of salts. A salt is not just sodium chloride, the kind that we eat and put on our table and put on our hamburgers and tomatoes. A salt is any kind of ionic substance. And these ionic substances are formed in an acid-base neutralization reaction. Look, for instance, at this first one. We've got hydrochloric acid, HCl, and sodium hydroxide being reacted together. Now, the first thing I always ask people to do is to label the acid, label the base, and then circle the appropriate species in that compound that indicates what it is. For instance, HCl is an acid, whereas NaOH is a base. And the part of HCl that makes it be an acid is that H at the beginning, and for the base, sodium hydroxide, it's that OH at the end. Now look at what happens when you combine. This is actually a double replacement type of reaction, but look at what happens when you end up with H and OH as a pair. When you do this double replacement reaction and you switch out these elements, the hydrogen and the hydroxide together produce what? Exactly, water. And because you're reacting an acid that has that hydrogen and a base that has that hydroxide every time, you're going to get water as one of the products of your reaction. So water as one of the products. Make sure that your reaction is balanced, and it's going to be easy to tell because the hydrogens and hydroxides will be balanced, will be equal, and if they are, you know you've got a balanced equation. If they're not, then I'm going to show you in a minute what you have to do when that situation occurs. So the rest of the compound that's still left over is the chloride and the sodium, and all we're going to do is put those two together. Now you could look up charges. Sodium's a positive and chlorine's a negative ion. So with that -1, +1, we know the formula is going to be NaCl, like we didn't know it already, since that is our normal table salt. But we can also tell because if we balanced our equation, we're going to be able to figure out the formula for that salt without ever having to look up the charges on those ions. So you'll see that happen in just a minute. But that's what I want to see right there. The only part of that I don't have to see is this little connecting arrow, and I'll put it in green like I usually do, the green for the part that you don't have to have. You don't have to have that connecting line between those two, and you don't have to underline the substances that are present other than the hydrogen and the hydroxide. But everything else has to be there and labeled if you want full credit for these problems. Look at the next one. Try the next one yourself really quick and see if you can do it on your own. Okay, hopefully you tried this, and hopefully you came up with the fact that this KOH is the base, and the HClO4 is the acid, and hopefully you circled the hydroxide in the base and the hydrogen in the acid, and wrote those down as the water formed. And now for the salt that's formed. We've got the K from the base, the ClO4 from the acid. Since this is already balanced 1 to 1, we don't have to look up the charges. Now if we did, potassium would be positive, the perchlorate, would be negative, but either way we would still get that the formula is simply KClO4. The metal always goes first, and then whatever part is with the hydrogen for the acid is going to go next for the ending of the salt. So that's what I want to see for that particular equation. Now let's look at some situations where it doesn't turn out evenly. Look at calcium hydroxide and hydroiodic acid. We have calcium hydroxide as the base. I'm hoping that you're picking that out easily. HI as the acid. And when you do the worksheet over this section, at the top of the worksheet, that's the first thing you're going to have to do, is to go through and label everything up at the top as being either an acid, a base, or a salt. So if it ends in OH, make sure you write that it's a base. If it starts with a hydrogen, it's an acid. But don't forget our two exceptions to the rule. I'm going to write them over here really quick just to remind you, and then erase them so we can do the rest of these problems. But remember that acetic acid, the main part in vinegar, is going to be an acid. It looks like a base because it ends with an OH, but it's an organic acid because it ends with that COOH at the end. The other one that you need to memorize and know is NH3, ammonia. Even though that doesn't end with a hydroxide and OH, that one is a base. So make sure you've labeled those two correctly. Everything else, if it's a metal plus a nonmetal, it's going to be a salt. So if it's not an acid or a base, and it's an ionic compound, and that's all really I put on the worksheet, then it's going to be labeled as a salt. So make sure you pay attention to those. So we've got the base, the hydroxide, we've got the acid with the hydrogen, and notice something that's a little bit different this time. We have two hydroxides with a calcium. So be careful. You want to make sure that the hydrogens and the hydroxides are balanced. Since there are two hydroxides here, you're going to want to make sure that there are two hydrogens in the acid. So once you know you have two hydroxides and two hydrogens, how many waters do you have? Yes, you have two. And once again, you could look up the charges on the calcium and the iodine. Calcium is a +2, and each of the iodines is a -1. So that would get you the formula. But look at our balancing. We've got one calcium over here. We've got two iodines over here. That tells us that the formula for our compound, metal first, remember, is going to be Ca, understood 1, I2. That's our salt. Makes it pretty simple. The next one, H2SO4 plus lithium hydroxide. See if you can do that one yourself real quick. Hopefully you tried that. Lithium hydroxide is a base. Our H2SO4 is an acid. Notice that we've got two hydrogens and one hydroxide present in this. So hopefully you notice that we're going to need two of the lithium hydroxides in order to make this balance correctly. And that's going to give us two waters. Two hydrogens and two hydroxides gives us two waters. And then look at the formula for the salt. Remember, the metal goes first. How many lithiums? 2. How many sulfates? 1. To give us our salt, lithium sulfate. Try the last one. If you can do this one, you can do any of them. So pause it for a minute and just see if you can get this one. So hopefully you labeled barium hydroxide as the base, and you labeled the phosphoric acid as your acid. You circled the hydroxides and the hydrogens, and notice this time that you have two hydroxides and three hydrogens. And hopefully you remembered our cross method. If you've got a 2 and a 3, you can cross those. In other words, we're going to have a 3 in front of here to give us a total of 6 hydroxides, and a 2 here to give us a total of 6 hydrogens. So 6 hydroxides, 6 hydrogens, what's that going to give us? Hopefully you got 6 waters. And then for the salt, remember, metal first, so the barium's going to go first, and think about how many bariums we have. We have 3, so Ba3, and look at the number of phosphates we have, 2. So PO4, put that in parentheses since it's a polyatomic ion, 2. And that's the salt for this problem.